Okay, everyone, with this video, we are going to go over question number 5 and question number 6. So question number 5 is based on topic 5, calculus, okay? And it has a maximum mark of 6. And it says that a particle moves in a straight line such that it passes through a fixed point O at the time t equals 0, where t represents the time measured in seconds after passing point O, for t value where it is between 0 and 10, and each velocity v meters per second is given by this formula here, or this equation here. And this equation is a sine function. Okay, and here we have graph of the v, and with this graph, what we know is we have this upper part, right, the positive part, and we do have negative parts. There's two parts. So the positive parts, let's talk about these positive parts first, right? This positive parts means that this particle is moving a positive direction, and also it means it is a forward. It has forward movement. Okay, then if you look at these two parts that are under the t-axis, right? We can say that these are the native. These are moving native direction. Okay, so moving native direction, and also we can say that this has the backward movement, right? Backward. Okay, then using this information, let's try the question A. We have to find the smallest value of the t when the particle changes its direction, right? So we have two cases where the particle changes their direction. They are this point here and this point here. And however, we need to find the smallest value of the t. We are referring to this point here, okay? Then for this question A, we are going to use the sine function, right? So v equals to sine 0.5t plus 0.3t minus 2. And we're going to use this function to find the smallest value of the t using the calculator, okay? So for your calculator, this is what you're going to do. Okay, so here I have your TI-84 plus calculator. Okay, so the first thing that you're going to do is you're going to make sure your calculator is in radian mode. So go to mode, okay? Make sure you check your calculator is in radian mode. Then you go to y equals button, so this button here, and you're going to type in your sine function. So 2 sine 0.5. Instead of t, I'm just going to use x because it's easier. Close the bracket, plus 0.3 x minus 2. Okay, and we're going to graph. So we are trying to find the smallest value. So means let's zoom this graph. I'm going to make x minimum as 0 and the y minimum as like maybe -5. Let's get the graph. Then you can see here. So what we're trying to do is we are actually trying to find this point here, right? The smallest point, or this or this. So what we're trying to do is we're trying to find this point here. You can see that the cursor is blinking, and this point is actually the first point that this graph intersects the t-axis, right, or x-axis. So in order to find this, we are going to calculate that intersection point by clicking second, calculate 2, and we're going to find our left one first. and we're clicking the right bound and we're going to guess. Then we get our zero, which is 1.68699 or 89, right? So we got the x point or t point, right? So t point is 1.68695 using calculator. Make sure you write this, right, to show that you use the calculator to find this answer. So and also the keystroke that I used was the second trace, and I used the 2 0, right? Then I got t value, and then of course you cannot leave your answer in this format. You have to leave your answer with the 3 suffix, right? So t value is equal to 1.69. Then let's look at the question B. So it says that the displacement of the particle is measured in meters from O. Find the range of the values of the t for which the displacement of the particle is increasing. So it means we have to, so what this displacement of the particles increasing means, we are trying to find that range that where the uh, particle is moving forward, right? So means we are trying to find this part here. Let's color this part. So where the particle is moving forward direction or the positive direction. So we are trying to find here, this point here. And what we know is we already found this point here as t equals 1.69. So we are trying to find this second t points, okay? So in order to do that, we are going to go back to the calculator, and we're going to find our second point. So again, second trace, zero, find your left bound first, and then you find your right bound and guess it. Then you get your second point, which is 6.1185707. You found your second point is 1.69, and second point you got 6.11897. However, again, we cannot leave our answers like this, right? We know that our T2 point is 6.12, so we can say that the T is between, or that we can say the values of the T where the displacement of the particle is increasing is between 1.69 and 6.12. So we got our answer. Okay, then let's look at the question C. Question C, we need to find the displacement of the particle related to O when t equals 10, right? So we do know that displacement, to calculate the velocity from the displacement, we have to differentiate, right? To calculate the uh, acceleration, right? Let's say our next one, acceleration. We have to again differentiate. However, if we want to go to velocity, or if we want to calculate the velocity from the acceleration, we have to integrate. Same thing, if we want to calculate the displacement from the velocity, we have to integrate again, okay? So it means to find the displacement of the particle related to O when t equals 10, we have to integrate this sine function, again, or sine equation. So we do integrate 0 to 10 sine function v of t dt, okay? And it means this is same as 10, 0 here, and I'm going to replace the v of t with the sine function equation, which is 2 sine 0.5 t plus 0.3 t minus 2, and close the bracket dt. At this point, you must be, okay, so do I have to do this manually? No, we actually can use GDC, right? So using GDC, we can click math button, right, on your calculator, and you go to 9 integral part, okay, and then you type in your sine function and then the range, and you get your answer. So let's do this together. So I'm going to quit, and I'm going to go here, and I'm going to go mathematics, and I'm going to go finite integration, which is 0.9, and I'm going to type in my numbers, 0 to 10, and my equation is 2 sine, and again, instead of t, I'm going to use x because it's just easier, and plus 0.3x minus 2, and don't forget to substitute x here and hit enter. Then you get negative 2.1346. So means your final answer is negative 2.1346, or you can just rewrite it as negative 2.13 with the correct sigma. Okay, then everyone, let's do question number 6 together. So this question is actually derived from topic 4, your statistic section, right? So this question is to compare the two sets of the data. So here we have a class test scores, right? Test A and test B. Each test is scored out of total 100 marks. The scores of the students are shown in the following table. Okay, and we have let X be on the score of on test A and Y be the score on test B. So X is test A and Y is test B. Okay, then here we have X be the score on test A. So X is test score for test A, and Y be the score on test B. So Y is test B scores. So, and it also says that the teacher finds that the equation of the regression line of y on x for these scores is y equals 0.822x plus 18.4. And question A, we need to find the value of the Pearson's product moment correlation coefficient, the R value. So that means we have to use our calculator, okay? So that means in order to use calculator, we have to type in these two sets of data into our calculator using the keystroke stat one edit. So we go to calculator and we go to stat one edit, and you're going to type in all our numbers. So 52, 71, 193, and we're going to go with the 58, 80, 98, 90, 82, 100, 100, 65, and 74. Okay, so once you are done typing these sets of the data, okay, we're going to find the value of the Pearson product moment correlation. So in order to do that, we're going to go for a second quit, okay, and we're going to go, then we're going to go to start, okay, and we're going to move our cursor to car, okay, and then we're going to hit number 4, okay, and your X list is L1, Y list is L2, and we go hit calculate, then we get our value here. Okay, then, you know, your calculator is supposed to show the R value, but my calculator doesn't. But, you know, there's a reason why, but that's my problem. But your calculator is going to show you the R value, right? So here we have a question. So R value is 0.901 from GDC. Okay, let's go over the keystroke for this question again. So we have to click stat right? And we move to car. We move the cursor to car, and we choose the number 4, linear regression, ax plus b, okay? And we set our x list as L1, y list as L2, okay? Then let's do the question B. So Giovanni was absent for test A and Paolo was absent for test B. The teacher uses the regression line of y on x to estimate the missing scores. So for the question A, we are for the question B, we are using the regression line of y on x, which is y equals 0.822x plus 18.4. Paulo scored 10 on test A, and the teacher estimated his score on test B to be 27 to the nearest integer using the following calculation, using the y on x regulation, right? Then why this is not appropriate for power for question B? Because, if you look at the power score, it's only 10. He only scored 10 on test A. And you can see that the test A set, right, score set, its lowest grade is 52. So 10 is way below than the range of the test A, right? So we can say that for the question B, 10 is way below than the range of test A. So the score is extrapolated. Okay, that was the answer for question B. Then next, Giovanni scored 90 on test B, and the teacher estimated his score on test A to be 87 to the nearest integer using the following calculation. So the issue right now is before we use the y on x regression line to estimate it. But with this question, with this equation, we are actually going backward, right? Now the test B is the input and then test A is output, okay? So this regression line is for test B on test A, not the test A on test B. So see, I give the reason why this method is not appropriate for Giovanni. Again, I just told you, because this regression line equation for test B on test A, not test A on test B. Then see, I use an appropriate method to show that the estimated test A score for Giovanni is 86 to the nearest integer. So for this question, we need to show we are using the correct linear regression model. Okay, so when we are trying, so with the question A, we just calculated the R value, right? But when we are doing that, we actually calculate the A and B value of the linear equation. So using the same idea, we're going to again go to stat car, and we're going to go for linear regression ax plus b, okay? And then we're going to set x list as L2, y list as L1. So by doing this, you're setting test B as input and test A as output, okay? So when you do this, you get the equation A equals 0.987124 times B minus 3.219. Okay, then you substitute your A value. Okay, so and the B to calculate the or you substitute your B value, which is the 90, to calculate the A value, which is 86. So you have to do so like this. For the final answer, what you need to do is you have to do a equals 0.987124 times 90 minus 3.219. Then you get a value 86. So you have shown that the estimated test A score for Giovanni's is 86 to the nearest integer. And that's it for this video. And stay tuned for my next video on this test. Thank you.